Today we're going to solve arithmetic series. Arithmetic series is the sum of all the terms in an arithmetic sequence. If the first and last terms of arithmetic sequence are given, we will use the formula S of n is equal to n over 2 times the quantity a sub 1 plus a sub n, where n is the number of terms, a sub 1 is the first term, and a sub n is the last term. The alternate formula that we can use is S of n is equal to n over 2 times the quantity twice the a sub 1 plus n minus 1 times d. Question number 1. Find the sum of the following arithmetic sequence, negative 12, negative 7, negative 2, positive 3, and so on, up to 488. For we to find the sum of this arithmetic series, we need to have three things. You need to have the a sub 1, the d, and your n. In this problem, our a sub 1 or the first term is negative 12. What is the common difference? The common difference here is adding by 5. So d is positive 5. And you can do that by subtracting negative 7 minus negative 12. You can also do negative 2 minus negative 7. Or 3 minus negative 2. And that is 5. So the pattern in this sequence is adding by 5. And at this time, we have the last term 488, but we don't know how many terms there are. So the first thing that we need to do is solve for the n using the arithmetic sequence formula. A sub n is equal to a sub 1 plus n minus 1 times d. A sub n is the last term, which is 488. A sub 1 is the first term, negative 12. Plus, we don't have the n yet, so we have n minus 1. And the common difference here is 5. Simplifying this, we have 488 is equal to negative 12. And then we will distribute the 5. That becomes 5n minus 5. Simplifying the right side, we have 488 is equal to negative 12 and negative 5 is negative 17. Then we have plus 5n. Now we add 17 to both sides. That is 505 is equal to 5n. Next, divide both sides by 5. Our n value here is 101. That means we have 101 terms total. Now we can solve for the sum using the formula S of n is equal to n over 2 times a sub 1 plus a sub n. Since there are 101 terms, this means we're solving for S of 101. N is 101, so we have 101 over 2 times a sub 1 is the first term, negative 12, plus the last term, that's 488. Simplifying this, we have 101 over 2 times negative 12 plus 488 is 476. Simplifying this further, we need to multiply 101 by 476 and then divide by 2. So the sum of this term is 24,038. That is our S of 101. Question number 2. Find the sum of the arithmetic series 56, 47, 38, 29, all the way to negative 124. For this series, our a sub 1 is 56. Our d value, the common difference is 47 minus 56, and that is negative 9. That means the pattern is subtracting by 9 to find the next term. We don't know the n value yet, so we need to use the formula a sub n is equal to a sub 1 plus n minus 1 times d to find the value for n. Our a sub n or the last term is negative 124. A sub 1 is 56. We don't have our n yet, so n minus 1 times the common difference is negative 9. Simplifying the right side, we have negative 124 is equal to 56. We now distribute negative 9 into the n minus 1. So negative 9 times n is negative 9n. Negative 9 times negative 1, that's plus 9. Simplifying the right side further, we have negative 124 is equal to 56 plus 9 is 65 minus 9n. Solving for n, we subtract 65 to both sides. Negative 124 minus 65 is negative 189. 65 and negative 65 is 0. We have negative 9n. Now we will divide both sides by negative 9. So n is equal to 21. That means there are 21 terms in this arithmetic series. So now we're ready to solve for the sum using the formula s of n is equal to n over 2 times a sub 1 plus a sub n. N is 21, so that means we're solving for the sum of 21 terms, that's S21, equals 21 over 2 times our a sub 1 is 56, and our last term is negative 124. Simplifying this, we have 21 over 2. Simplifying 56 plus negative 124, that is negative 68. Simplifying this further, we have 21 times negative 68, and then divide by 2. That gives us negative 714. This is the sum of the 21 terms in this arithmetic series. Question number 3. Find the sum of the arithmetic sequence negative 4, negative 11, negative 18, all the way to negative 102. Our first term is negative 4. Our common difference is negative 11 minus negative 4, and that is negative 7. We don't know the n value yet, so we're going to use the arithmetic sequence a sub n is equal to a sub 1 plus n minus 1 times t. Our a sub n, or the last term, is negative 102. A sub 1 is negative 4, and we have n minus 1 times the common difference is negative 7. Simplifying the right side, we have negative 102 is equal to negative 4. Distribute the negative 7, we have negative 7n, and then plus 7. Simplifying the right side further, we have negative 102 is equal to negative 4 plus 7 is 3, we have minus 7n. Now we need to subtract 3 to both sides. This becomes negative 105 is equal to negative 7n. Now divide both sides by negative 7. N value here is 15. Now that we already have a sub 1, d, and n is 15, we can solve now for the sum of the n terms using s of n is equal to n over 2 times a sub 1 plus a sub n. Since we have 15 terms, we're solving for s sub 15. And that is 15 over 2 times a sub 1 is negative 4. And the last term is negative 102. Simplifying this, we have 15 over 2 times negative 4 plus negative 102 is negative 106. Simplifying this further, 15 times negative 106 divided by 2 is equal to negative 795. This is the sum of the first 15 terms in this arithmetic sequence. Question number 4. Find the sum of the series negative 1.2 plus 0.3 plus 1.8 all the way to 12. Our a sub 1 is negative 1.2. The value of d, or the common difference, is 0.3 minus negative 1.2, and that is 1.5. We don't have the value of n yet, so we will solve that using a sub n is equal to a sub 1 plus n minus 1 times d. Our a sub n, or the last term, is 12.3. First term is negative 1.2. N minus 1 times the common difference of 1.5. Simplifying the right side, we have negative 1.2 plus 1.5n minus 1.5 by doing distributive property. Simplifying this further, we have 12.3 is equal to negative 1.2, and negative 1.5 is negative 2.7 plus 1.5n. Now we need to add 2.7 to both sides. 12.3 plus 2.7 is 15, is equal to 1.5n. Dividing both sides by 1.5, our n value here is 10. That means there's 10 terms in this arithmetic series. So now let's find the sum using s sub n is equal to n over 2 times a sub 1 plus a sub n. We have 10 terms, so we're solving for s sub 10. We have 10 over 2, a sub 1 is negative 1.2, and a sub n is 12.3. Simplifying this, 10 divided by 2 is 5. Negative 1.2 plus 12.3 is 11.1. Multiplying 5 and 11.1, this is 55.5. So the sum of the 10 terms is 55.5. Question number 5. Find the sum of this sequence. The first term here is negative 1/4. The value of d here, or the common difference, is 1/4 minus negative 1/4. That's 2/4, or the same thing as 1/2. We don't have the n value yet, so we're going to solve for n using a sub n is equal to a sub 1 plus n minus 1 times d. A sub n is 3 3/4. Our a sub 1 is negative 1/4. And we have n minus 1 times d, which is 1/2. Simplifying this, we have 3 3/4 is equal to negative 1/4 plus, distribute the 1/2, we have 1/2 n minus 1/2. Simplifying this, we have 3 3/4 is equal to negative 1/4 minus 2/4, or 1/2, is negative 3/4 plus 1/2 n. Now we will add 3/4 to both sides, and that becomes 3 6/4, or that's the same thing as 4 1/2, or 9 over 2, is equal to 1/2 n. Multiplying both sides by 2, this means that n is equal to 9. So there are 9 terms in this arithmetic series. Now we will solve for the sum using s of n is equal to n over 2 times a sub 1 plus a sub n. We're solving for the sum of the 9 terms, so that's s of 9. We have 9 over 2. First term is negative 1/4, and the last term is 3 3/4. Simplifying this, we have 9 over 2. Negative 1/4 plus 3 3/4 is 3 2/4, or that's the same thing as 3 1/2, or 7 over 2. So multiplying 9 over 2 and 7 over 2, this is 63 over 4. And in mixed number, this is the same thing as 15 3/4. So this is the sum of the 9 terms. Thank you for watching, and please consider subscribing to my channel at Celzo Academy.